Okay, good afternoon, Professor C and Professor Kang and everyone. This is my pleasure to have present today. I come back to the more than 14 years ago. I have a seminar with Professor Z like you now. And today I talk a little bit about what I have done after I graduate. I concentrate on the smooth frame for the play and share structures. And I have the three parts. First, I would like to introduce myself and what is the current research, and I would like to have for the future research. Okay, as you know that I entered the lab in 2007, and I got the BD in 2011 from Professor Z. Is my lab member of the same lab. After graduate, I became a lecturer of the civil engineering faculty for 3 years, and you see that after that I got the position of Dean and Dean for 10 years, and that's why I don't have a lot of time to build my research group, because a lot of time I have to save for the administrator job, but I have to maintain the research workload for the university. So I choose the direction is suitable for my position in numerical methods. I developed smooth finite methods for the trinode triangle plane and cell element. The smooth frame is included an S-base, node-base, or cell-based smooth frame. And I concentrate on the MIT-C3 and MIT-C3 plus element because this element I studied while I was a BD student. And after that, I utilize this element to analyze the bending, frequency, and buckling analysis of plane and share. It's not only isotropic material, but I apply for the laminatic composite material, functionally graded material, porous material, multi-layer functionally graded graphene nanoplate reinforced composite. I think there are lots of material model now, so I can apply this element to this and by on the first order shear deformation theory or higher order shear continuation. And this research trend is suitable for me when I work at the on the desk, not by a lot of the experiment analysis. And the first one I would like to talk a little bit about the shell-based smooth MIT-C3 plus element with the drilling degree of freedom system. At the time, I used the bending approximation from the MIT-C3, and main frame is I use the Allman time, and then I have the displacement approximation for the element, and I use the MIT-C3 shear removal locking technique to reduce the shear effects of the element, and I developed the smooth frame for this element. We call it the shell-based smooth frame. And thanks to this technique, I could transform the surface integration into the line integration by on the green theory. So I can get the more actually the integration of the stiffness matrix. And from this element, I have some application related to the shell structure, maybe the isotropic shell structure. I will compare with the current element. For example, here is our element. I developed this element, and the other one is the current element that have already published, and I feel it's the better. It's the main our objective. So that's the reason I can write the paper, something like this. And maybe I apply for the laminatic composite place, and I just change the material model. And I can show some the benchmark problem in the laminatic composite cell, and I also to compare with the published element with the analytical solution to find is the good solution or our element can improve the accuracy, something like this. Now I am guiding one BD student. He helped me to coding and show some new material, maybe a porous material, and we apply for the shell with the high shear or deformation theory. I think it's not so new, but we have a time and we make the code to solve the problem in the high order shear deformation. Because for the isotropic material, the first order shear deformation is the good, but for the I think the new material we need some complicated material model, and we also investigate the effect of the order factor on the material on the behavior of the structure, something like this. And I also apply the other method, smooth method, might be the S-based smooth method. Why we call it S-based smooth method? Because as you know that the three node triangle is a very low accuracy because of they deal the low approximation displacement. So the strength field within each element usually the constant. So we average the strength between the elements, so we can reduce the difference between the strength between element. And at this element we also apply for the plate structure, because we apply only for the plate structure, because if we apply for the shell structure, it's very difficult for us to project or smooth on the adjacent element because it's not the same length. And I also apply this element for porous material, something like this. I can analyze the bending of frequency, something like this. And here we can see that is the analytical solution, and we can get the solution nearly approach to the analytical solution. We apply for the buckling place, and we continue to develop this element for the functional grade graphene nanoplate reinforced composites. And it's just different on the material model, but I can apply for this and verify, because as you know that nowadays there are lots of advanced material, numerical methods for the ICA or messless methods, but I try to use a simple element, so I think the result is also valuable for application. I also work for the bending frequency and maybe the buckling for this kind of plate. And now I and my BD student want to study the AI or similar methods to predict the behavior of the structure, depend on the random characteristic of the material property, and we can predict. And I think this is a very potential direction for the application. And I also study the other numerical methods, but I think the finite method also have the area for us to develop and apply. And of course, I would like to have a lot of conversation with Professor Z when I graduate, but unfortunately I don't have a lot of time to work what he thinking about this. And I have my colleagues in the Faculty of Civil Engineering. We have a lot of laboratory and a lot of professors from different area can have the cooperation with your lab and Gong's lab for the civil engineering area. Okay, thank you very much.
You are still working on the field of computational mechanics.
Yes, because I think it's suitable for me because I just write a course.
But it's time for you to switch to other research because you have to lead other professors as possible.
Yeah, I hope so. But I really like to apply the AI or machine learning in the research.
It's a really good subject. And then I have a colleague.
Yes.
Who developed a full set of commercial package.
Yeah. Okay.
But do you know Professor Kim?
He have an X and 5 and S software.
Yeah, X.
I know.
But he has been retired.
Retired. Yeah.
And then his PhD, former PhD student Hasim.
Yeah.
went back to Thailand. But they still want to make a business for their company Canada to hold in
Yeah.
Thailand. But if you are interested in still in the field of the computation or Canada method, maybe they are good. They can be a good contact.
Yeah, yeah.
Maybe I think it's good.
I think it's good because not only me, because in our faculty we have group of the numerical simulation.
No.
So if we have a trained collaboration, and
Sure.
my colleagues will work with them.
And then I'm very pleased to note that Thanh, Professor Chau-Dinh, and he was my first international student, but who really engaged in actual research activity. And then the fund that I supported him from ADD, defense, that was defense research. We work for the multi-craft development for Korean air fighter. That was my first multi-year research project, supported by Defense of Ministry and the Ministry of Defense.
Yes.
We had very fun. Okay, thank you very much.
Okay, thank you.